2.5 million light-years away, a silent giant drifts through the darkness, its spiral arms unfurling like cosmic ribbons. The Andromeda Galaxy, our nearest galactic neighbor, has always been a source of fascination and mystery. For centuries, it was just a faint smudge in the night sky, a ghostly presence that seemed to watch us as much as we watched it. But now, with the advent of the James Webb Space Telescope, humanity has peered deeper into Andromeda's heart than ever before. What we found there has shaken the foundations of astronomy, rewriting what we thought we knew about galaxies, black holes, and the fate of our own Milky Way. On a crisp autumn night, you might look up and see Andromeda as a pale blur in the constellation Cassiopeia. Most people pass by without a second thought, unaware that they're gazing at a galaxy containing 1 trillion stars, each one a sun, many with their own planets, perhaps even life. But Andromeda is not just a distant curiosity. It is a cosmic juggernaut, a galaxy twice the size of our own, and it is on a collision course with us. For decades, astronomers have tracked its approach, calculating that in 4 billion years, Andromeda and the Milky Way will merge in a titanic event that will reshape both galaxies forever. Yet, as dramatic as that future is, it was the present that stunned scientists when James Webb turned its golden mirrors toward Andromeda's core. Unlike Hubble, which sees the universe in visible light, Webb peers into the infrared, revealing structures and energies hidden behind veils of dust. What it saw was not the quiet, orderly galaxy we expected. Instead, Webb uncovered signs of turmoil, distorted clouds of gas, filaments of superheated material, and, at the very center, a supermassive black hole that appears to be waking from a long slumber. The story of Andromeda is a story of violence and survival. Galaxies are not peaceful islands. They are arenas of gravity where the strong consume the weak. Andromeda has spent billions of years devouring smaller galaxies, leaving behind streams of stars as evidence of its cannibalistic past. Its halo is littered with the remnants of these cosmic victims, their stars now part of Andromeda's vast population. But the real monster lies at the core, a black hole 140 million times the mass of our Sun, wrapped in layers of gas and ancient stars. For years, astronomers believed this black hole was dormant, a sleeping giant that occasionally snacked on a stray gas cloud or unlucky star. But Webb's observations revealed something different. The core of Andromeda is alive with activity. Gas clouds are spiraling inward at unexpected speeds, heated to temperatures that defy standard models. Dust rings glow with infrared light, their shapes twisted and broken, as if disturbed by recent violence. And the black hole itself is emitting bursts of radiation, flares that ripple through the galaxy and hint at a new phase of activity. What does it mean when a supermassive black hole wakes up? The consequences are profound. Active black holes can reshape entire galaxies, blasting jets of energy that suppress or trigger star formation, stirring up gas and dust, and even altering the orbits of stars. In Andromeda, Webb's data suggests that the black hole's feeding rate is increasing, and with it, the potential for chaos. The galaxy's core is no longer a quiet place. It is a cauldron of energy, and the effects are spreading outward. But the surprises didn't stop there. Webb's infrared vision pierced the dust lanes of Andromeda, revealing star-forming regions that had been invisible to previous telescopes. In these hidden nurseries, new stars are being born at rates that challenge our understanding of how galaxies evolve. Some regions are far more active than models predicted, while others are strangely quiet. The distribution of star formation is patchy and uneven, suggesting that Andromeda's history is more complex and more violent than we realized. The implications for the future are staggering. As Andromeda and the Milky Way draw closer, their halos, vast clouds of hot gas and dark matter, are already beginning to overlap. The collision has, in a sense, already begun. When the galaxies finally merge, the chaos at Andromeda's core could make the event far more violent than anyone expected. Two supermassive black holes, both potentially active, will spiral toward each other, unleashing gravitational waves and bursts of energy that will echo across the universe. Yet, amid the turmoil, there is beauty. Webb's images of Andromeda are breathtaking, revealing intricate structures of dust and gas, glowing filaments, and clusters of newborn stars. The galaxy is not just a site of destruction, it is also a cradle of creation, where the cycle of birth and death plays out on a cosmic scale. Every star, every cloud, every flare from the black hole tells a story of matter and energy, of time and gravity, of the universe itself. As we begin this journey into Andromeda's heart, remember that what we see is not just a distant spectacle. It is a preview of our own future, a mirror held up to the Milky Way. The discoveries made by James Webb are not just about another galaxy. They are about us, about where we came from, where we are going, and what it means to be part of a universe that is both terrifying and magnificent. The first time humanity realized that Andromeda was not just a nebula within our own galaxy, but a vast island universe in its own right, it changed our understanding of the cosmos forever. Edwin Hubble's observations in the 1920s revealed that Andromeda lay far beyond the Milky Way, a revelation that expanded the universe overnight. Since then, Andromeda has been a touchstone for astronomers, a nearby laboratory where we can study the processes that shape galaxies everywhere. But for all our progress, Andromeda has always kept its secrets well hidden, shrouded in dust and distance, its true nature just out of reach. That veil began to lift with the launch of the James Webb Space Telescope. Webb's infrared eyes can see through the thickest clouds of dust, revealing the hidden machinery of galaxies. When Webb turned toward Andromeda, scientists expected to find answers to old questions. How do spiral arms form and persist? What triggers bursts of star formation? How does a galaxy's central black hole influence its evolution? Instead, they found new mysteries, evidence that Andromeda is not the stable, mature galaxy we thought, but a dynamic, restless system in the midst of transformation. At the heart of these discoveries is the black hole. For decades, astronomers have studied the supermassive black holes at the centers of galaxies, searching for patterns and connections. They found that the mass of a galaxy's central black hole is closely linked to the mass of its bulge, suggesting that black holes and galaxies grow together, each shaping the other's fate. In the Milky Way, our own black hole, Sagittarius A*, is relatively quiet, emitting only faint X-rays and radio waves. Andromeda's black hole, by contrast, is a behemoth, more than 30 times as massive, and now, it seems, far more active. Webb's observations revealed filaments of gas spiraling into the black hole, heated to thousands of degrees by friction and magnetic fields. These filaments glow in the infrared, tracing the paths of matter as it falls toward oblivion. In some regions, the gas is moving faster than gravity alone can explain, hinting at the presence of powerful magnetic fields or even jets of material being ejected from the black hole's poles. The accretion zone, the region where matter piles up before crossing the event horizon, is turbulent and chaotic, a maelstrom of energy that defies easy explanation. But perhaps the most unsettling discovery was the increase in X-ray flares and neutrino bursts coming from Andromeda's core. X-ray telescopes like Chandra have monitored the galaxy for years, recording occasional outbursts as the black hole consumed a gas cloud or star. But since 2006, the frequency and intensity of these flares have risen, and neutrino detectors on Earth have picked up bursts of ghostly particles arriving from Andromeda's direction. Neutrinos are produced in the most extreme environments, supernova, gamma-ray bursts, and the accretion disks of active black holes. Their presence suggests that Andromeda's black hole is entering a new phase, one that could have dramatic consequences for the entire galaxy. What could be causing this awakening? One theory is that Andromeda recently captured a dense cloud of gas, or perhaps the remnant of a smaller galaxy. As this material spirals inward, it feeds the black hole, triggering bursts of activity. Another possibility is that the black hole is naturally cycling between dormant and active states, a process that may be common in galaxies but rarely observed in real time. Whatever the cause, the implications are profound. An active black hole can drive powerful winds and jets, expelling gas from the galaxy's core and shutting down star formation. It can also trigger new waves of star birth by compressing gas clouds in the surrounding regions. Webb's data shows both effects at work. In some parts of Andromeda, star formation is surging, with clusters of young, hot stars lighting up the spiral arms. In others, the gas is being blown away, leaving behind barren regions where no new stars can form. The balance between creation and destruction is delicate, and it is shifting before our eyes. The galaxy we see today is not the galaxy that existed a million years ago, and it will not be the same a million years from now. This dynamic interplay is not unique to Andromeda. Across the universe, galaxies grow and change through a process of mergers, accretion, and feedback. But Andromeda offers a rare opportunity to watch these processes unfold in detail. Its proximity allows us to resolve individual star clusters, map the distribution of gas and dust, and track the motions of stars as they respond to the gravitational pull of the black hole. Every new observation adds a piece to the puzzle, revealing a galaxy in flux, shaped by forces both internal and external. The stakes are not just academic. The fate of Andromeda is entwined with our own. As the two galaxies approach, their halos have already begun to interact, exchanging streams of gas and dark matter. The collision, when it comes, will be a slow-motion catastrophe, stretching over billions of years. Stars will be flung into new orbits, some ejected into intergalactic space, others drawn into the merged core. The black holes at the centers of both galaxies will spiral together, eventually merging in a burst of gravitational waves that will ripple across the cosmos. For now, we watch and wait, our understanding deepened and unsettled by what Webb has revealed. The universe is not a static backdrop, but a living, evolving entity full of surprises and dangers. Andromeda is both a warning and a promise, a reminder that even the most familiar objects can hold secrets beyond our imagination. The revelations from James Webb's gaze into Andromeda have forced astronomers to rethink not only the galaxy's present, but its entire history. For decades, the prevailing view was that Andromeda was a relatively mature, stable spiral galaxy, a cosmic elder sibling to the Milky Way. Its stately arms, vast bulge, and immense population of stars seemed to suggest a system that had long since settled into equilibrium. But the new data paints a far more turbulent portrait, one of a galaxy still bearing the scars of ancient violence, still hungry, still changing. One of the most striking discoveries is the evidence of Andromeda's cannibalistic past. Webb's infrared vision, combined with deep imaging from Hubble and other observatories, has revealed streams of stars in Andromeda's halo, long, faint ribbons that arc around the galaxy, remnants of smaller galaxies that were torn apart and absorbed over billions of years. These stellar streams are not random. They are the fossil record of cosmic collisions, each one a signature of a galaxy that once existed independently, now reduced to a trail of stars. By analyzing the chemical composition and ages of these stars, astronomers can reconstruct Andromeda's merger history. Some streams are ancient, dating back 10 billion years. Their stars pour in heavy elements, relics of the early universe. Others are more recent, the debris of galaxies consumed just a few billion years ago, their stars richer in metals, evidence of more advanced stellar evolution. The sheer number of these streams, over 100 identified so far, testifies to Andromeda's voracious appetite. It has grown not by peaceful accretion, but by conquest. This process of galactic cannibalism is not unique to Andromeda. The Milky Way, too, is in the process of devouring smaller galaxies, such as the Sagittarius dwarf. But Andromeda's history is more dramatic, its mergers more frequent and more massive. This may explain why Andromeda is nearly twice as large as the Milky Way, with a more massive bulge and a greater population of globular clusters, dense, ancient star clusters that orbit the galaxy. Like a swarm of bees, each globular cluster is a survivor, a remnant of a galaxy that was destroyed, its core preserved as a tight knot of stars. Webb's observations have allowed astronomers to study these clusters in unprecedented detail. By measuring the brightness and color of individual stars within the clusters, scientists can determine their ages and chemical compositions, tracing their origins to specific merger events. Some clusters are native to Andromeda, formed in the galaxy's youth. Others are immigrants brought in by captured galaxies. The distribution and motion of these clusters reveal the invisible structure of Andromeda's dark matter halo, the vast, unseen mass that holds the galaxy together. But the story is not just one of destruction. Each merger, each act of cannibalism, has also been an act of creation. When a smaller galaxy plunges into Andromeda, its gas is compressed and shocked, triggering bursts of star formation. Webb's infrared images show regions where new stars are being born in the wake of these collisions, their light shining through the dust that once hid them from view. These stellar nurseries are the engines of galactic renewal, recycling the debris of the past into the stars of the future. Yet, even as Andromeda continues to grow, it is also changing in ways that may signal the end of its star-forming era. Webb's data shows that the overall rate of star formation in Andromeda is lower than in the Milky Way, despite its greater mass. Much of the galaxy's gas has been used up or blown away by supernova and black hole-driven winds. The remaining gas is concentrated in a few dense clouds, where star formation proceeds in fits and starts, rather than in a steady, galaxy-wide process. This patchiness is a clue to Andromeda's future. As the galaxy ages, it will gradually exhaust its supply of star-forming material. The bursts of creation triggered by mergers will become less frequent, and the galaxy will settle into a quieter, redder phase, dominated by old, cool stars. But before that happens, one final, cataclysmic event awaits: the collision with the Milky Way. The approach of Andromeda is not just a distant curiosity, it is a cosmic inevitability. The two galaxies are bound by gravity, their mutual attraction drawing them together at a speed of over 100 kilometers per second. Their halos are already touching, their outermost stars and gas clouds mingling in the darkness between. In a few billion years, the main bodies of the galaxies will begin to merge, their spiral arms twisting and distorting as they pass through each other. Simulations of this event show a spectacular but chaotic process. Stars will be flung into new orbits, some ejected into intergalactic space, others drawn into the dense core of the merged galaxy. Gas clouds will collide and compress, triggering a final burst of star formation, a cosmic fireworks display that will light up the night sky. At the center, the two supermassive black holes will spiral together, eventually merging in a titanic release of energy. What will remain is not a spiral galaxy, but a giant elliptical, a bloated, featureless cloud of stars, its structure shaped by the violence of the merger. The Milky Way and Andromeda, once distinct, will be gone, replaced by a new galaxy, Milkomda, as some astronomers call it. The legacy of billions of years of cosmic evolution, written in the orbits of stars and the glow of ancient light. The collision between the Milky Way and Andromeda is often imagined as a sudden, catastrophic event, but in reality, it will unfold over billions of years, a slow-motion ballet of unimaginable scale. From our vantage point on Earth, the first signs will be subtle. Andromeda will grow larger and brighter in the night sky, its spiral arms stretching across the heavens. Over millions of years, the two galaxies will draw closer, their mutual gravity distorting their shapes, pulling out long tidal tails of stars and gas. The night sky will become a living canvas, painted with the light of 1,000,000,000,000 suns. As the galaxies approach, their halos, vast, invisible clouds of hot gas and dark matter, will interact first. These halos are already overlapping, their boundaries blurred by the exchange of material. Recent studies using the Hubble Space Telescope and the James Webb have shown that the halos of the Milky Way and Andromeda extend for hundreds of thousands of light years, far beyond the visible disks where they meet. The gas is compressed and heated, creating a diffuse bridge between the galaxies. This bridge is a harbinger of the merger to come, a sign that the process is already underway. When the main bodies of the galaxies finally collide, the effects will be dramatic, but not apocalyptic. Despite the vast number of stars in each galaxy, the distances between them are so great that direct collisions are exceedingly rare. Most stars will pass by each other unharmed, their orbits altered by the shifting gravitational landscape. Some will be flung into the outer reaches of the new galaxy, becoming intergalactic wanderers. Others will be drawn into the dense core, where the combined gravity of the two supermassive black holes will dominate. The real fireworks will come from the gas clouds. As the galaxies interpenetrate, their clouds of hydrogen and helium will collide at high speeds, compressing and heating the gas. This will trigger a burst of star formation on a scale never before seen in either galaxy. Massive, hot blue stars will ignite, their light outshining the older, cooler stars around them. These new stars will live fast and die young, exploding as supernova and enriching the surrounding gas with heavy elements. The cycle of creation and destruction will reach its peak, a final act of cosmic renewal before the galaxies settle into their new form. At the heart of the merger, the two supermassive black holes, one from the Milky Way, the other from Andromeda, will begin a slow, spiraling dance. Over millions of years, they will draw closer, their orbits decaying as they lose energy to gravitational waves. When they finally merge, the event will release a burst of gravitational energy so powerful that it will ripple across the universe, detectable by future generations of astronomers on distant worlds. The merged black hole will be even more massive, a true monster at the center of the new galaxy. For any civilizations that might exist in the distant future, the view from within the merged galaxy will be both familiar and strange. The orderly spiral arms of the Milky Way and Andromeda will be gone, replaced by a vast, featureless cloud of stars. The night sky will be darker, with fewer bright stars, but the central bulge will glow with the combined light of two galaxies. The legacy of the merger will be written in the orbits of stars, the distribution of globular clusters, and the chemical composition of the gas and dust. But the story does not end there. The merged galaxy, Milky, will continue to evolve, slowly consuming any remaining satellite galaxies and star clusters. Over trillions of years, star formation will dwindle as the supply of gas is exhausted. The galaxy will grow redder and dimmer, its population dominated by long-lived red dwarfs and the remnants of dead stars. Eventually, even the black hole at the center will quiet, its feeding slowed to a trickle as the last gas clouds are consumed. Yet, even in this distant future, the echoes of the past will remain. The streams of stars left behind by ancient mergers, the shells and ripples in the galaxy's halo, the distribution of globular clusters, all will tell the story of how Milky came to be. Astronomers of the far future, if any remain, will be able to reconstruct the history of their galaxy by studying these clues, just as we do today with Andromeda and the Milky Way. The James Webb Space Telescope has given us a preview of this future, revealing the processes at work in Andromeda's core and halo. Its observations have shown that galaxies are not static, but living, evolving systems, shaped by the forces of gravity, star formation, and black hole activity. The universe is a place of constant change, where even the most familiar objects can surprise us with their complexity and dynamism. As we look ahead to the merger of the Milky Way and Andromeda, we are reminded of our own place in the cosmos. Our sun, our planet, and our species are just tiny parts of a much larger story, a story that began billions of years ago and will continue for billions more. The discoveries made by James Webb are not just about distant galaxies. They are about the nature of the universe itself and our connection to it. The revelations from James Webb's observations of Andromeda have not only deepened our understanding of galactic evolution, but have also sparked new questions about the very nature of the universe. For every answer the telescope provides, it seems to uncover two new mysteries, each more profound than the last. This is the paradox of discovery. The more we learn, the more we realize how much remains hidden in the cosmic dark. One of the most compelling contrasts revealed by Webb is the difference between what we see in visible light and what is unveiled in the infrared. To the naked eye, Andromeda appears as a serene, spiral galaxy, its arms gracefully winding around a bright core. But in the infrared, the picture is far more complex. Webb's instruments have exposed vast networks of dust lanes, glowing filaments, and turbulent clouds that are invisible in ordinary light. These structures are not just beautiful, they are the engines of change, the sites where stars are born and die, where gas is heated and expelled, and where the fate of the galaxy is decided. Take, for example, the dust rings that encircle Andromeda's core. In visible light, these regions appear dark and empty, obscured by thick clouds of interstellar dust. But Webb's infrared vision reveals them as vibrant, dynamic structures, glowing with the heat of embedded stars and warm molecular clouds. The innermost ring, just a few thousand light years from the black hole, is dense and rich in organic molecules, complex compounds that are the building blocks of life. The temperature gradients across these rings tell a story of recent star formation, of massive stars igniting and blasting their surroundings with ultraviolet radiation, heating the dust and causing it to shine in the infrared, but the dust rings are not uniform. Webb has detected gaps, clumps, and distortions that suggest recent disturbances, perhaps the passage of a satellite galaxy or the influence of jets from the central black hole. In some places, the dust is being blown away, creating clear channels through which we can peer deeper into the galaxy's heart. In others, The dust is compressed into dense knots, the birthplaces of new stars. The interplay between these forces, creation and destruction, order and chaos, is what gives Andromeda its unique character. Another striking contrast is found in the rates of star formation across the galaxy. Traditional models predicted that Andromeda, with its immense mass and rich supply of gas, should be a prolific star factory. But Webb's data tells a different story. While some regions are indeed bursting with new stars, others are strangely quiescent, their gas reservoirs depleted or blown away. The reasons for this patchiness are still being debated, but it is clear that Andromeda's history of mergers and black hole activity has played a major role. Each collision, each burst of energy has left its mark, shaping the distribution of gas and the pattern of star birth. Perhaps the most unsettling discovery, however, is the evidence that Andromeda's black hole is not as dormant as once believed. The increase in X-ray flares and neutrino bursts suggests that the black hole is entering a new phase of activity, one that could have far-reaching consequences for the entire galaxy. Active black holes are among the most powerful engines in the universe, capable of launching jets of particles at nearly the speed of light, heating and expelling gas, and even shutting down star formation in their host galaxies. If Andromeda's black hole continues to wake up, it could transform the galaxy in ways we are only beginning to understand. This awakening is not just a local phenomenon. Across the universe, astronomers are finding evidence that black holes and galaxies are intimately connected, their fates intertwined. The mass of a galaxy's central black hole is closely linked to the mass of its bulge, suggesting a feedback loop in which the growth of one influences the other. Webb's observations of Andromeda provide a rare opportunity to study this process in action, to watch as a galaxy responds to the stirring of its central monster. The implications for the future are profound. As Andromeda and the Milky Way draw closer, the activity at their cores could make the eventual merger far more violent than previously imagined. Two active black holes, each feeding and expelling energy, could create shockwaves that ripple through the merged galaxy, triggering bursts of star formation and reshaping the orbits of stars. The collision will not be a gentle blending of two spirals, but a chaotic, energetic event that will echo across the cosmos. Yet, amid the uncertainty, there is also hope. The same processes that drive destruction also create new possibilities. The bursts of star formation triggered by mergers and black hole activity will seed the galaxy with new generations of stars and planets, perhaps even new sites for life to emerge. The cycle of birth and death, of chaos and order, is the engine of cosmic evolution, and Andromeda is a living testament to its power. As we peer deeper into Andromeda's mysteries, the story becomes not just one of cosmic violence, but of intricate balance, a dance between forces that build and forces that destroy. The James Webb Space Telescope has given us the ability to see this balance in action, to witness the interplay of gravity, radiation, and chemistry on a scale that defies imagination. Each new image, each spectrum, is a window into the processes that have shaped not only Andromeda, but galaxies throughout the universe. One of the most fascinating aspects of Webb's discoveries is the role of molecular clouds in the galaxy's evolution. These vast, cold reservoirs of gas and dust are the cradles of star formation, the places where gravity gathers material until it collapses to ignite new suns. In Andromeda, Webb has mapped these clouds with unprecedented detail, revealing their complex internal structure. Some are long, filamentary threads stretching across hundreds of light years. Others are dense, compact knots where star formation is most intense. The temperature and chemical composition of these clouds vary from region to region, reflecting the history of mergers, supernova, and black hole activity that have shaped the galaxy. Within these clouds, Webb has detected a rich array of molecules: water, carbon monoxide, ammonia, and complex organics. These compounds are not just the raw material for stars, but also for planets and, potentially, life. The presence of organic molecules in Andromeda's star forming regions raises tantalizing questions about the possibility of life elsewhere in the universe. If the same chemistry that gave rise to life on Earth is at work in Andromeda, then perhaps the galaxy is home to countless worlds where life has taken hold, each with its own story to tell. But the molecular clouds are not static. They are shaped and reshaped by the forces at work in the galaxy. Supernova explosions send shockwaves through the clouds, compressing some regions and dispersing others. Winds from massive stars and active black holes carve out bubbles and cavities, creating a turbulent environment where star formation is both triggered and suppressed. Webb's observations show that the rate of star formation in Andromeda is not uniform, but varies dramatically from place to place, depending on the local balance of these forces. This patchwork of activity is mirrored in the distribution of star clusters across the galaxy. Some regions are rich in young, hot stars, their light piercing the dust and illuminating the surrounding gas. Others are dominated by older, cooler stars, the remnants of past generations. By studying the ages and compositions of these clusters, astronomers can reconstruct the history of star formation in Andromeda, tracing the ebb and flow of creation over billions of years. The story of Andromeda is also a story of dark matter, the invisible substance that makes up most of the galaxy's mass. Webb's data, combined with measurements of the motions of stars and clusters, has allowed astronomers to map the distribution of dark matter in unprecedented detail. The results are both reassuring and unsettling. On the one hand, they confirm the basic predictions of cosmological models. Dark matter forms a vast, diffuse halo around the galaxy, providing the gravitational glue that holds it together. On the other hand, the detailed structure of this halo is more complex than expected, with clumps and streams that reflect the galaxy's violent history of mergers and accretion. These findings have implications far beyond Andromeda. They challenge our understanding of how dark matter behaves, how galaxies form and evolve, and even the fundamental laws of physics. If the structure of Andromeda's dark matter halo cannot be fully explained by current models, then perhaps our theories need to be revised. Webb's observations are pushing the boundaries of knowledge, forcing scientists to confront the limits of what we know and to imagine new possibilities. Amid all this complexity, one thing is clear: Andromeda is not a finished product, but a work in progress. The galaxy is still growing, still changing, still responding to the forces that shape it. The discoveries made by James Webb are a reminder that the universe is a place of constant evolution, where even the most familiar objects can surprise us with their dynamism and diversity. For those of us on Earth, these revelations are both humbling and inspiring. We are part of a universe that is far more intricate and interconnected than we ever imagined. The story of Andromeda is, in a sense, our own story, a story of origins, of change, of the endless interplay between chaos and order. As we continue to explore the cosmos, guided by the light of distant galaxies and the insights of powerful telescopes, we are reminded that the quest for knowledge is never-ending, and that every answer is just the beginning of a new question. The more we learn about Andromeda, the more it becomes clear that galaxies are not isolated islands, but nodes in a vast cosmic web. The space between galaxies, once thought to be empty, is now known to be filled with tenuous gas, dark matter, and the faint echoes of ancient interactions. Andromeda's story is woven into this larger tapestry, its fate linked not only to the Milky Way, but to the entire local group of galaxies, a gravitationally bound family that includes dozens of smaller companions. James Webb's observations have illuminated the relationships between Andromeda and its satellite galaxies. These smaller systems, some containing only a few million stars, orbit the giant like moths around a flame. Their orbits are not random, many move in a coherent plane, a structure that has puzzled astronomers for years. Theories abound. Perhaps these satellites are the remnants of a larger structure that fell into Andromeda's gravity well, or maybe they were captured along cosmic filaments that thread the universe. Whatever their origin, their fate is sealed. Over time, gravitational interactions will drag them inward, where they will be torn apart and absorbed, their stars joining the growing halo of Andromeda. Webb's ability to resolve individual stars in these satellite galaxies has opened a new window on galactic archaeology. By measuring the ages, motions, and chemical compositions of these stars, astronomers can reconstruct the histories of the satellites and their interactions with Andromeda. Some show signs of recent star formation, triggered by close encounters with the giant. Others are ancient, their stars enriched with the heavy elements produced by generations of supernova. The diversity of these systems is a testament to the complexity of galaxy formation, a process shaped by both local conditions and the broader environment of the cosmic web. But the satellites are not the only companions shaping Andromeda's destiny. The Triangulum Galaxy, the third largest member of the local group, is itself on a slow, looping orbit around Andromeda. Webb's data suggests that Triangulum may one day join the merger between Andromeda and the Milky Way, adding its stars and gas to the mix. The result will be a truly colossal galaxy, the product of billions of years of cosmic evolution and interaction. These interactions are not just a matter of gravity. As galaxies pass close to one another, their gas clouds can collide, triggering bursts of star formation. Webb has observed regions in Andromeda where such interactions have left their mark, star clusters aligned along the paths of infalling satellites, streams of gas and stars stretching between galaxies, and shock fronts where gas has been compressed and heated. These features are the fingerprints of past encounters, preserved in the structure of the galaxy. The cosmic web itself is a source of material for Andromeda. Filaments of gas and dark matter connect galaxies across vast distances, channeling fresh material into their halos. Webb's sensitive instruments have detected faint streams of gas flowing into Andromeda, replenishing its supply of star-forming material. This ongoing accretion is a crucial part of the galaxy's evolution, providing the fuel for new generations of stars and helping to maintain the delicate balance between creation and destruction. Yet, even as Andromeda grows, it is also losing material. Galactic winds, driven by supernova and black hole activity, are blowing gas out of the galaxy and into intergalactic space. Webb's observations have revealed the structure of these winds, filaments and bubbles of hot gas streaming away from the core, carrying with them the heavy elements forged in the hearts of stars. Over billions of years, this process will enrich the space between galaxies, seeding the cosmic web with the ingredients for future generations of stars and planets. The interplay between inflow and outflow, between accretion and feedback, is what shapes the destiny of galaxies. Andromeda is a living example of this balance, a system in which the forces of growth and loss are in constant tension. Webb's discoveries have shown that this balance is not static, but dynamic, shifting in response to the galaxy's history and environment. For astronomers, these insights are a treasure trove. Each new observation adds a piece to the puzzle, helping to build a more complete picture of how galaxies form, evolve, and interact. For the rest of us, they are a reminder of the grandeur and complexity of the universe, a universe in which even the nearest galaxy is a world of endless wonder and surprise. As the James Webb Space Telescope continues to reveal Andromeda's secrets, it also challenges our assumptions about what it means to be a galaxy. For much of the 20th century, astronomers imagined galaxies as relatively simple systems, collections of stars, gas, and dust, shaped by gravity and evolving slowly over time. But the reality, as Webb has shown, is far more intricate. Galaxies are dynamic ecosystems, their histories written in the language of mergers, feedback, and chemical evolution. Each new discovery adds depth to the story, revealing layers of complexity that were previously invisible. One of the most profound lessons from Webb's observations is the importance of feedback processes in shaping galaxies. Feedback is the term astronomers use to describe the ways in which stars and black holes influence their surroundings. When massive stars reach the end of their lives, they explode as supernova, releasing energy and heavy elements into the interstellar medium. This energy can trigger new waves of star formation, but it can also blow gas out of the galaxy, shutting down further star birth. Similarly, when a supermassive black hole becomes active, it can launch jets and winds that heat and expel gas, regulating the growth of the galaxy. In Andromeda, Webb has observed both sides of this feedback loop. Regions near the core show evidence of powerful outflows, with gas being driven away by the activity of the central black hole. At the same time, other regions are experiencing bursts of star formation, fueled by the compression of gas in the wake of mergers and interactions. The balance between these processes determines the fate of the galaxy, whether it continues to grow and form new stars, or whether it enters a period of quiescence, its star forming days behind it. The chemical fingerprints left by these processes are visible in the spectra collected by Webb. By analyzing the light from different regions of Andromeda, astronomers can measure the abundance of elements like carbon, oxygen, and iron. These elements are the products of stellar nucleosynthesis, forged in the hearts of stars and distributed by supernova and winds. The patterns of enrichment across the galaxy tell a story of repeated cycles of creation and destruction, of gas being enriched, expelled, and reaccreted over billions of years. This chemical evolution is not just an academic curiosity, it has profound implications for the possibility of life elsewhere in the universe. The elements necessary for life as we know it, carbon, nitrogen, oxygen, phosphorus, and sulfur, are all produced by stars and distributed by feedback processes. Webb's discovery of complex organic molecules in Andromeda's star forming regions suggests that the raw materials for life are widespread, not just in our own galaxy, but throughout the cosmos. If planets form in these regions, as they do in the Milky Way, then the potential for life is vast, limited only by the imagination. But the story of Andromeda is also a story of limits. As the galaxy ages, its supply of star-forming gas is gradually depleted. The bursts of star formation triggered by mergers and feedback become less frequent, and the galaxy settles into a quieter phase. Webb's data shows that Andromeda is already forming fewer stars than the Milky Way, a sign that it is entering the later stages of its evolution. The future will be dominated by old, red stars, the remnants of a more active past. Yet, even in this quieter phase, Andromeda remains a place of change. The ongoing interactions with its satellites, the slow accretion of material from the cosmic web, and the ever-present influence of its central black hole ensure that the galaxy will never be truly static, Webb's observations remind us that galaxies are not monuments, but processes, constantly evolving, shaped by the interplay of forces both seen and unseen. For humanity, these discoveries are a source of wonder and perspective. We are part of a universe that is alive with activity, where even the nearest galaxy is a world of complexity and surprise. The story of Andromeda is a mirror for our own story, a reminder that change is the only constant, and that the quest to understand the cosmos is a journey without end. The journey of discovery that James Webb has enabled is not just about distant galaxies, it is also about our own origins and destiny. As we unravel the secrets of Andromeda, we gain new insights into the forces that shaped the Milky Way, the processes that forged the elements in our bodies, and the cosmic events that will one day determine our fate. The story of Andromeda is, in many ways, the story of us. Consider the parallels between the two galaxies. Both the Milky Way and Andromeda are massive spirals, each with hundreds of billions of stars, vast clouds of gas and dust, and a supermassive black hole at the center. Both have grown through a long history of mergers and accretion, cannibalizing smaller galaxies and incorporating their stars and clusters. Both are surrounded by halos of dark matter, invisible but essential, providing the gravitational glue that holds them together. And both are on a collision course, destined to merge in a cosmic event that will reshape the local group forever. Webb's observations have highlighted the similarities and differences between these two giants. While Andromeda is larger and more massive, it is also further along in its evolution, with a lower rate of star formation and a more active central black hole. The Milky Way, by contrast, is still relatively rich in gas, with ongoing star formation in its spiral arms and a quieter core. These differences are the result of their unique histories. Andromeda's more violent past, with frequent mergers and interactions, has accelerated its evolution, while the Milky Way's quieter environment has allowed it to retain more of its star-forming material. The impending collision between the two galaxies is a subject of intense study and speculation. Simulations suggest that the merger will unfold over billions of years, with multiple close passes before the final coalescence. During this process, the orderly structure of both galaxies will be disrupted, their spiral arms twisted and torn, their stars flung into new orbits. Some stars, including perhaps our own Sun, may be ejected into the outer reaches of the merged galaxy, or even into intergalactic space. Others will be drawn into the dense core, where the combined gravity of the two supermassive black holes will dominate. The fate of the solar system in this cosmic drama is uncertain. The vast distances between stars mean that direct collisions are unlikely, but the gravitational chaos of the merger could alter the Sun's orbit, changing the view of the night sky for any future inhabitants of Earth. Over time, the merged galaxy Milkomda will settle into a new equilibrium, its structure shaped by the violence of the collision and the ongoing influence of its central black hole. Webb's data has also shed light on the broader context of this event. The local group is not an isolated system, but part of a larger network of galaxies connected by the cosmic web. The merger of the Milky Way and Andromeda will be just one chapter in a much longer story. As the local group gradually coalesces into a single, massive galaxy over the next 100 billion years. The processes we observe in Andromeda today, mergers, feedback, chemical evolution, are the same processes that will shape the future of our own galaxy and the universe as a whole. For astronomers, the ability to study Andromeda in such detail is a gift. Webb's infrared vision allows us to peer through the dust, to see the birth and death of stars, to map the distribution of gas and dark matter, and to trace the history of mergers and interactions. Each new discovery adds to our understanding of how galaxies form and evolve, and how the universe itself has changed over time. For the rest of us, these discoveries are a source of awe and inspiration. They remind us that we are part of a vast, interconnected cosmos, shaped by forces that operate on scales both immense and minute. The atoms in our bodies were forged in the hearts of stars, scattered by supernova, and gathered into new generations of stars and planets. The story of Andromeda is, ultimately, the story of how the universe creates and recreates itself over and over in an endless cycle of birth, death, and renewal. As the James Webb Space Telescope continues its mission, the revelations from Andromeda serve as a powerful reminder of the importance of perspective. From our small vantage point on Earth, it is easy to feel insignificant in the face of such cosmic grandeur. Yet, the very act of observing, of seeking to understand, connects us to the universe in a profound way. The photons that Webb collects from Andromeda have traveled for millions of years, crossing the void to reach our instruments. In decoding their message, we become participants in a story that began long before our species existed and will continue long after we are gone. The discoveries Webb has made in Andromeda are not just scientific milestones, they are also deeply human achievements. They are the result of generations of curiosity, ingenuity, and collaboration. The telescope itself is a marvel of engineering, the product of decades of effort by thousands of scientists, engineers, and visionaries from around the world. Its success is a testament to what humanity can accomplish when we work together, driven by a shared desire to explore and understand. This spirit of exploration is reflected in the questions we ask about Andromeda. What triggers the awakening of a supermassive black hole? How do galaxies regulate their own growth, balancing the forces of creation and destruction? What role do mergers and interactions play in shaping the structure and destiny of galaxies? Each answer leads to new questions. Each discovery opens new frontiers. The pursuit of knowledge is a journey without end, a process of continual refinement and expansion. Webb's observations have also highlighted the interconnectedness of the universe. The processes at work in Andromeda, star formation, feedback, mergers, chemical evolution, are not unique to that galaxy. They are universal, operating in galaxies near and far, shaping the cosmos on every scale. By studying Andromeda, we learn not only about a distant neighbor, but about the fundamental laws that govern the universe itself. This interconnectedness extends to the possibility of life. The detection of complex organic molecules in Andromeda's star, forming regions, suggests that the ingredients for life are widespread, not confined to the Milky Way. If planets form in these regions, as they do in our own galaxy, then the potential for life elsewhere in the universe is vast. The same processes that forged the elements in our bodies are at work in Andromeda, creating the conditions for life to emerge and evolve. The story of Andromeda is also a story of time. The light we see from the galaxy left its stars and gas clouds millions of years ago, long before humans walked the Earth. In observing Andromeda, we are looking back in time, witnessing events that shaped the galaxy's present and will influence its future. The collision with the Milky Way, though billions of years away, is already underway in a sense. Their halos are mingling, their destinies intertwined. For future generations, the legacy of Webb's discoveries will be a foundation for new explorations. As technology advances, new telescopes and instruments will build on what we have learned, probing deeper into the universe and uncovering new mysteries. The questions we ask today will become the stepping stones for tomorrow's breakthroughs, each generation adding its own chapter to the story of cosmic discovery. In the end, the most important lesson from Andromeda may be one of humility and wonder. The universe is vast, complex, and ever-changing, filled with beauty and danger, creation and destruction. Our place in it is small, but not insignificant. By seeking to understand the cosmos, we affirm our connection to it and to each other. The story of Andromeda is our story, a story of curiosity, courage, and the unending quest to know. The narrative of Andromeda, as revealed by the James Webb Space Telescope, is a tapestry woven from countless threads, threads of light, matter, and time. Each observation adds a new color, a new texture, to our understanding of the galaxy and, by extension, the universe itself. The more we study Andromeda, the more we realize that its story is not just about stars and gas, but about the fundamental processes that govern all of existence. One of the most striking aspects of Webb's findings is the way they challenge our sense of cosmic permanence. For much of human history, the night sky seemed eternal and unchanging, a backdrop against which the drama of life played out. But the reality, as Webb has shown, is far more dynamic. Galaxies are born, grow, collide, and transform. Stars are created in bursts of brilliance, live out their lives, and die in spectacular explosions. Even the most massive structures in the universe are subject to change, shaped by forces that operate over billions of years. This realization brings with it a sense of both awe and responsibility. As inhabitants of a small planet orbiting an ordinary star, we are the product of cosmic evolution, a process that began with the Big Bang and continues to this day. The atoms in our bodies were forged in the hearts of stars, scattered across space by supernova, and gathered into new generations of stars and planets. Our existence is a testament to the power of the universe to create complexity from chaos, order from disorder. Webb's observations of Andromeda have also deepened our understanding of the role of black holes in galactic evolution. Once thought to be mere curiosities, black holes are now recognized as central players in the life cycles of galaxies. Their influence extends far beyond their immediate surroundings, shaping the distribution of gas, regulating star formation, and even determining the ultimate fate of their host galaxies. The awakening of Andromeda's central black hole, as revealed by Webb, is a reminder that these objects are not just endpoints, but engines of change. The interplay between black holes and their galaxies is a subject of ongoing research. Webb's data has provided new insights into the mechanisms by which black holes feed, the ways in which they expel energy, and the impact of their activity on the surrounding environment. These findings have implications not only for our understanding of Andromeda, but for galaxies throughout the universe. By studying the details of one galaxy, we gain clues to the workings of many. Another key lesson from Webb's exploration of Andromeda is the importance of looking beyond the visible. The universe is filled with phenomena that cannot be seen with ordinary light. Infrared, ultraviolet, X-rays, and radio waves all reveal different aspects of reality. Webb's ability to see in the infrared has opened up new vistas, allowing us to peer through dust, to study the birth of stars, and to map the distribution of molecules and elements. Each wavelength tells a different part of the story, and together they create a richer, more complete picture. The discoveries made by Webb are not the end of the story, but the beginning of a new chapter. As we continue to explore Andromeda and other galaxies, we will undoubtedly encounter new mysteries, new challenges, and new opportunities for discovery. The universe is a place of endless possibility, and our journey of exploration is far from over. For those who look up at the night sky and wonder, the message from Andromeda is clear. The cosmos is alive with change, filled with stories waiting to be told. The light that reaches us from distant galaxies is a message from the past, a record of events that shape the present and will influence the future. By listening to these messages, by seeking to understand their meaning, we become part of the grand narrative of the universe. As we approach the end of this journey through Andromeda's secrets, it's worth reflecting on what these discoveries mean for us, not just as scientists or astronomers, but as human beings. The James Webb Space Telescope's revelations have transformed Andromeda from a distant smudge in the sky into a living, evolving world, rich with drama and complexity. We now see it not as a static object, but as a dynamic system shaped by forces both familiar and strange, its fate intertwined with our own. The story of Andromeda is, in many ways, a story of perspective. From Earth, the galaxy appears serene and unchanging, a symbol of cosmic stability. But Webb's observations have shattered that illusion, revealing a galaxy in flux, a place where stars are born and die, where black holes awaken and sleep, where the scars of ancient collisions are written in streams of stars and clouds of dust. The processes that shape Andromeda are the same ones that have shaped the Milky Way, and by extension, the solar system and the planet we call home. This cosmic kinship is a source of both humility and hope. It reminds us that we are not alone in the universe, that the forces that created us are at work everywhere, forging new worlds and new possibilities. The elements in our bodies, the water in our oceans, the air we breathe, all are products of the same cosmic alchemy that lights the stars of Andromeda. In this sense, the galaxy is not just a neighbor, but a distant relative, a branch on the same cosmic family tree. The future of Andromeda and of the Milky Way is a future of change. The collision between the two galaxies, already underway in the mingling of their halos, will be a slow, majestic dance, unfolding over billions of years. It will bring chaos and creation, destruction and renewal. New stars will be born, old ones will die, and the merged galaxy, Milkomda, will become a monument to the power of gravity and time. For any life that endures to witness this event, the night sky will be transformed, filled with the light of 1,000,000,000,000 suns. But perhaps the most profound lesson from Webb's exploration of Andromeda is the reminder that the universe is not something that happens to us. It is something we are part of. Our curiosity, our drive to explore, our ability to ask questions and seek answers, these are as much a part of the cosmos as the stars and galaxies themselves. In seeking to understand Andromeda, we are, in a very real sense, seeking to understand ourselves. The journey does not end here. The questions raised by Webb's discoveries will inspire new generations of astronomers, new missions, new technologies. Each answer will lead to new mysteries, each discovery to new horizons. The universe is vast, and our exploration of it has only just begun. So the next time you look up at the night sky and see that faint smudge of light in Cassiopeia, remember what it truly is: a galaxy alive with change, a witness to cosmic history, a harbinger of our own future. Remember that the light you see began its journey millions of years ago, long before humans walked the earth, and that it carries with it the story of creation, destruction, and renewal. And remember, above all, that in seeking to understand Andromeda, we are taking part in the greatest adventure of all, the adventure of knowing the universe and our place within it.